So we're going to move into chapter 3. So chapter 3, we're going to study quadratic functions. Quadratic functions. So actually in the textbook we use 3.1 and 3.2 actually go back and go over lines in a lot of detail. We're not going to do that. We've already looked at lines back in section 1.3. You've got to know your lines. But we want to move on to 3.3. So it's going to be section 3.3. We're looking at quadratic functions. We're going to start looking at them in their forms. So what is a quadratic function? We're going to talk about, first of all, the general form of a quadratic function. Say a function that may be written in the form y equals ax squared plus bx plus c. So a, b, and c are numbers. Call those real numbers. So they could be fractions, they could be decimals, they could be whole numbers, they could be negative numbers. Yeah. A, b, and c are just real numbers. With a not zero. A is not allowed to be 0. So possibly b and c could be 0, but a is not allowed to be 0. So basically you have to have a square term as your largest power term showing up here to be a quadratic. Is a quadratic function. That's the formal definition of a quadratic function. Anything that can be written in the form y equals ax squared plus bx plus c. A, b, and c are real numbers. A is not 0. That's called a quadratic function. Okay. This is one way to write a quadratic function. It turns out that you can actually write quadratics in a different way. If you do some factoring and some manipulation, you can get what's called the vertex form of a quadratic. Form of a quadratic function. So the vertex form of a quadratic function, a quadratic function may be written in the form y equals a times x minus h squared plus k, where h comma k, that's these numbers here, is the vertex of the function's parabolic graph. And of course, this a here, this a is going to determine if it's a positive, it's going to be opening upward. So a is going to tell you how it opens. So if a is positive, it opens upwards. If a is negative, it's going to open downwards. And what else? If a is a positive that's bigger than 1, then it's going to be a vertical stretch. If a is a positive that's smaller than 1, it's going to be a vertical compression. So hk is the vertex of the function's parabolic graph. And yeah, a tells you your stretch or compression factor and also tells you the direction it's opening. So I'll write if a is positive, the parabola opens upwards. If a is negative, and the parabola opens downwards. It tells you your orientation of your parabola. Yeah, so basically, if it's opening upwards, I'll be doing like this. It'll be like a U shape opening up like that. If it's opening downwards, it'd be something like that, an upside down U. Important information. So what we want to do, we want to graph some quadratic functions. Now we already know how to use transformations of graphs from section 2.5, so that's what we're going to do here. So just go do some exercises. Graph the parabola. So a parabola is a U-shaped graph of a quadratic function. So number one, let's say I have y equals 3 times x plus 2 quantity squared plus 1. So we know this is a squaring function, right? Basic quadratic is y equals x squared, so that's your parent. That's the most basic parabola you can have. And after we graph that, we're going to then do the first transformation where there's a 3 out in front of the house. So if you have a 3 out in front of the house, what does that do? Oh, let's make it red. 3 out in front of the house, that's going to multiply all your y values by 3, right? Multiply your y values by 3 from the previous parent. So it's a vertical stretch by a factor of 3. So vertical stretch by 3. If I can spell stretch. So then you go to your next transformation when you have a plus 2 inside of the house. So inside of the house is a horizontal motion since it's a plus 2. So inside of the house is the opposite of the sign. So you're going to move left 2 rather than right 2. So left 2. And then finally you have this plus 1 outside of the house. So plus 1 is, or outside of the house rather, outside of the house is vertical motion. It's going to be in the same direction of the sign when it's outside the house. So it's going to be up 1. So I will actually think about this. So I'll have enough space? I don't know. 1, 2, 3, 4. I think so. I think I'll have enough space. Yeah. Yeah, I have enough space, I think. So how do you start this? Well, you start off with square negative 2 and you get 4. This is the parent. Square negative 1, you get 1. Square 0, you get 0. Square 1, you get 1. Square 2, you get 4. Okay, so this is using transformations. And then I would stretch everything out by a factor of 3. So I'm going to multiply the y values by 3. So when I'm at negative 2, 4, I multiply the 4 by 3 and I get 12 here. I get negative 3, 12. When I'm at negative 1, 1, negative 1, 1, I'm going to multiply the y value of 1 by 3 and I get negative 1, 3. And when I take 0, 0, and I multiply the y value of 0 by 3, I get 0, so 0, 0 stays. 1, 1, when I'm at 1, 1, I multiply the y value of 1 by 3, I get 3, so I get 1, 3. When I'm at 2, 4, it's right here. 2, 4, multiply the 4, the y value by 3, I get 12, so I get 212. Right, and we're going to move left 2 everything. So I'm going to start with negative 212 and move left 2 to negative 412. I'm going to take negative 1, negative 1, 3, and move left 2. I'm going to get negative 3. That was negative 1, 3 is moving left 2 and get negative 3, 3. 0, 0 is moving left 2 and get negative 2, 0. I'm going to connect these blue points on the left side. It's not great, is it? Let's try it again. Okay, and I'm going to take on the right now, the red point, which is at 1, 3. I'm going to move it left 2, and I get negative 1, 3. And finally, the red point, which is at 2, 12, and move it left 2, and I get 0, 12. I'm going to connect those. Get something like that. Oh, I should have probably made a dashed line here. Is there a way to get a slightly smaller? There we go, that's better. Okay, so we got the blue, and now we're going to do the purple. We're going to move everything up 1. Starting in the far left with the blue there, I got, was it negative 412 is going to move up. It's not one on the right here. Up 1. Here at negative 2, 3, we're going to move up 1. Here at negative 2, 0, we're going to move up 1. Here at negative 1, 3, we're going to move up 1. And here at 0, 12, we're going to move up to 0, 13, and we're going to connect these. That didn't work too well. There we go. So the purple one is my final graph. So the purple one is y equals 3 times x plus 2 squared plus 1. So this is actually using the old transformations method. Now you don't actually have to use this method. You can kind of use the vertex form if you want. So we said, let me show you the vertex method. So I'll show you another method. So you got y equals 3 times x plus 2 squared plus 1. So remember the vertex form is y equals a times x minus h squared plus k. So what we're going to do, we're going to rewrite what we have. We're going to leave the 3 out front. So the 3 here, 3, I'm going to make that red. 3 is going to be a. So I can leave that 3 there. Then in parentheses, I'm going to have x minus something squared plus something. Okay, so I want to make sure that my plus 2 stays the same quantity inside of the parentheses, so we're going to make it minus negative 2. Minus negative 2, right? If I write x minus negative 2, that's the same thing as x plus 2. So that's going to be my h there is going to be minus 2, because we want x minus h inside of the parentheses. And then outside of the parentheses, we want a plus a k. Well, that's just going to be simply the 1 there. So that'll be the k. So basically you identify your vertex here is hk. It's going to be negative 2 comma positive 1. So another way to think about this is, okay, I got a 2 here. You take the opposite sign of that one, so it's negative 2. And then you have a plus 1 here, and you take the same sign as that one. So outside of the house, you take the same side. Inside of the house, you take the opposite sign. So negative 2, 1 is the vertex. And then you have this factor of scaling factor. This is called your scaling factor. Your vertical, I'll call it vertical scaling factor. That's in red, it's the 3. So we can graph it using these 3 bits of information. I'll show you how that's done. So this is not quite using the same transformation methods that we're using before. So you'll start off with negative 2, 1 as your vertex. Let's do this. 1, 2, 1. The question is, am I going to have enough space? I don't think so. Let's give me a little more space. Go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, good. 1, 2, 1, 2, 3, 4. All right, so I'd start off with the vertex at negative 2, 1. I'll plot that here. Now, normally, when you're doing the typical y equals x squared parabola, you would first go from the center, you go right 1, up 1. All right, I go up 1, right 1. Let's say up 1, right 1. But because we have the scaling factor here of 3, we're going to go up 3 and then right 1. And normally we would go up 1, left 1 for our parabola, but we're going to go up 3. Well, that's not 3, is it? Let me try that one more time. See, we go 1, 1, 2, 3, and right 1. And then we do, normally we go up 1, left 1 for our next point on the left. So we go 1, 2, 3, left 1. So this is taking into account the scaling factor of 3. And then normally when you're dealing with the standard y equals x squared, to find your next point on your graph, you would go up 4 over 1, up 4 over 1. But we're going to multiply by a scaling factor of 3, so we're going to go up 12 over 1 from the green point. This is from the green point, so we're going to go 1, if I can write, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then, sorry, right 2, 1, 2. That'll be right here. Okay, and then you do the same thing but to the left. You would go up 12 and then left 2, 1, 2. And then you can just connect those. Yeah, and it's the same exact graph as that purple one from before. It's a kind of a quicker way to do it without going through the transformations. Yeah, so basically you have to know the key points of the standard, right? Y equals x squared. Let me explain that one more time. So you have like 0, 0. Negative 1, 1. 1, 1. You have negative 2, 4. And you have 2, 4. This is the standard y equals x squared. So the idea is you have these side points here. This one and this one. This is our first pair of side points, right? So from the center of the vertex, you go up 1 and right 1. And you go up 1 and left 1 to get to this blue, right? Up 1 and right 1. And then up 1 and left 1. But because we had the scaling factor of 3, we went up 3, 1, 2, 3, and right 1. And we went up 3 and left 1. And that's how we're getting those first pair of points from our starting place, our vertex. Now also, when you go back to the original y equals x squared function, you get your second pair of points. Let's make that in an orange color. these 2 points. So you start at your vertex, and normally you would go up 4, 1, 2, 3, 4, and right 2, and up 4 and left 2 to get these 2 orange points. So what we've done in our graph, rather than going up 4 and right 2 and up 4 and left 2, we've gone up 12 and right 2 and up 12 and left 2 because our scaling factor is 3. So we have to multiply the 4 by 3. So rather than going up 4, right 2, up 4, left 2, we go up 12 because 4 times 3 is 12. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then we go right 2, and then we go left 2. And that's how we got those points there. Yeah, that's kind of a alternate way to do it without directly using the transformations. It's a quicker way. I like doing it that way myself. All right, so you can use that method for thinking about things. Let's do another example. Y equals minus, parentheses x minus 2 squared minus 2. So I'm not going to use transformations on this one. I'm going to use the vertex method. The vertex method. So the first thing you would do is identify your vertex and your A. So first of all, A here is the number in front here. That's actually negative 1. And your vertex, so your H here is going to be 2. And your K is going to be minus 2. So the vertex, you can say is 2 and negative 2. Right? Remember the form. Remember the form is y equals A times x minus h squared plus k. So basically I matched this h up with this 2, and that's how I got h is 2. And I matched this minus 2 up here with this k here, and I got minus 2 for my k, and for my a, I matched a up with the minus 1 in front. Okay, so the quick way of graphing this without going through all the transformations is to first begin with the vertex, 2, negative 2. So I'll put the vertex right there, 2, negative 2. Okay? Now, normally the graph would open upwards as a parabola, but because we have this negative number out front, negative 1, it's going to open downward, so it's going to go upside down. Upside down. So normally you start at your vertex, right, and you go up 1, right 1, and up 1, left 1. But instead of doing that, we're going to go down 1, right 1, and down 1, left 1 to find additional points. And we'll put these points here to the side. Yeah, I'm going to start my graph doing this, like that. So normally you go up 1, right 1, up 1, left 1, but I'm going to go down 1, right 1, down 1, left 1. That's because our scaling factor here is negative. And normally then you would go what? Up 4, right 2, and up 4, left 2. But we're going to go down 4, right 2, and down 4, left 2 to find additional points. So let's use a different color for those. I don't know, purple. I'm going to go 1, 2, 3, 4 down, and then right 2. And I'll plot a point there. And then I'll do the same down 4, and then I'll go left 2. 1, 2, and I'll plot a point there. So when I connect those, I get this kind of upside down U shape. Now that's the quick way to do it without actually using the transformations. Yeah, it's a nice way to do it. No, you can use transformations if you want. All right, so I think we'll pick up